Hi, I'm Frank Grimberg, a Dynamics 365 Power Platform architect. I've spent the last 10 years training Dynamics 365 implementers. As I exit the training market, I want to drop some of my content in an area that I see a lot of bad or missing information. This material is focused on Dynamics 365, CDS, Common Data Service, plugins, developer information. If you are not familiar with the concepts, please visit docs.microsoft.com. To understand how plugins work, we need to understand the plugin pipeline stages and images. To explain how the plugin pipeline works, we're going to focus on an update from a user pressing save on the form. As a developer, we can inject code in the stages of the pipeline to do work on the data. Think of SQL triggers. The slide shows the stages, and on the top bar shows that the user is waiting for the form to return back to their screen. The bottom bar is when the pipeline is within a transaction. Pre-validation happens outside of the transaction and has a few security considerations to take into account. This is a great place to validate data before entering a transaction. If there is a problem, we can send a message back to the user. Pre-operation, most importantly, is in the transaction. Write, there's nothing we can do here because the database is actually being written to. Post-operation sync, since the write is successful, we can now work on child records. Maybe even the current record that triggered the update. Since we are in the transaction, if there is an issue, we can just roll back the entire transaction. And finally, the post-operation async, which is a great place to do work that the user should not wait for and doesn't need to be in a transaction. We have a few rules we want to follow. Have the user wait the least amount of time possible. Stay in the transaction the shortest amount of time possible. Lock as few records as possible within the transaction. And one more that we'll discuss in a minute. When the user presses save, the pipeline is triggered. What is important here are the collections that are available to us inside each stage. We have three primary collections: pre-image, what the fields look like when the form was presented to the user; post-image, what the fields are after the write; and target. I call that the change collection because that contains only the fields that have changed. I'm going to focus in on pre-image and target, or the change field collection. What is interesting is I can change what is in the change field collection before the write stage, and all my changes will be applied to the record. Whereas if I try to change the fields on the post-operation sync, I need to issue an update statement again, which will then make a recursive call. We'll explore more of the impact of recursive calls later in the video. So our fourth rule is try not to have a post-operation sync update the record that triggered the pipeline. We want to try to avoid the recursive call. When I am called into customers' review of plugins, I check the solution and SDK message processing steps. Yes, there will be many post-operation sync calls because this is the logical place to put logic for working with child records. What I look for are there any pre-validation or pre-operation plugins. If so, then I know the developer has a basic understanding of pipeline stages. Many times I have seen only post-operation sync, which raises a red flag. When writing query code, we're able to query the tables, entities, in three primary ways: query expression, fetch XML, and link. I've written a blog post about this and will include a link in the description. As I go over the capabilities of each, the most important takeaway is the no lock option on queries. Remember our rule about locking as little as possible? This is why every query you need to decide no lock or not. When reviewing code, I often see developers using the depth variable to see if the plugin is in a recursive call and exiting if it is greater than 1. Don't do this. The depth can be different based on how the record was created. Let's take a look at some of my code here and then watch it in action to see what I'm talking about. This is a plugin that will be attached to the account create pre-validation. So whenever a record is created, it will stuff into the description field. My depth is whatever the current depth is. You can see that we're grabbing the depth here when the plugin is called. So let's see what happens now. I'm going to manually add a new account record. I'm going to call this test coming from the form. We're going to press save and close. And you'll see that test form is created. My view is showing me the description. And we're now seeing that this is my depth is level 1, which is what you would expect, and most developers that are checking depth are assuming is the case. Let's have a little bit of fun here. And we're going to import from a CSV file. I will go out and grab an account, just one account. And let's go ahead and import. Okay, give it a second for the import engine to run. And now we have test from import. The interesting thing is that the my depth is actually at level 2, not level 1. I've actually seen ways to actually start the record to being created at depth 4. So if you have code that's trying to manage recursive calls checking depth, this is a mistake because you can't trust what depth is going to be. You can never guarantee that it's going to start at 1 based upon the way that the record is created. Let's play a recursive game. Here's my sample code. This plugin is attached to the contact update post operation sync. And what it does is it will update the manager name field with m plus depth. And what we will do is we'll store in the description field what the pre-image and post-image value of the manager name field is. So it would be a M1, M2, M3, M4, or it could be blank. And this will end up going in a recursive call, and we are using context.depth to get out of it. I know I said never do that, but just for this testing, we're going to do it. So you need to figure out what is in the pre-image and post-image at each level. So here's an Excel template that shows us the game, which is basically you need to figure out what is the pre-image and post-image value of the manager field. It would be M1, 2, 3, 4, or blank. You just have to figure out it. This will be in a recursive call, so it's going to go through 4 times. So I'm going to give you a minute here. I'm going to keep the screen up here for a minute. You can scribble down, figure out what you want, and then we'll see what the results are. Okay, so let me go ahead and issue the update on the contact record. And you'll see that we now have the description back. It's kind of long, so I'm going to paste it over into a Visual Studio Code, a little bit easier for us to see, and I will utilize this to fill out our Excel spreadsheet. So hopefully you got this correct, but I can tell you, first of all, CDS is doing nothing wrong. It's doing exactly what it should be doing. So if you think about it, we are looking at the post image and pre-image at level 1 of the post operation sync. So basically, the pre-image is correct because nothing's been updated yet. And the post image is correct on level 1 because nothing's been updated yet. So in the post operation sync is actually when we issue the update statement, which forces the recursive call. Now you see that at the next level, we still have blank in the pre-image, and the post image now shows M1. And then the next level down, we have M1 and M2 and so on. So it is doing exactly what it should be doing. So the issue here is that if you're in a recursive call, it's hard for you as the developer to know if you are getting the right information with inside the pre-image. I've seen many customers say, hey, look in the audit log, there's this number in the field, but the calculation comes up blank. That's a pretty obvious situation to me that it's a recursive call, and they're looking at the pre-image and it's blank at the time. So what I'm really saying here is that CDS is doing exactly what it should, but it is unfair to you as a developer to know or to be able to depend upon the pre-image when you're in a recursive call. I am, as a plugin developer, dependent upon the pre-image to know what was there before so I can figure out what's changed and how I want to do calculations and so on. So this is very important. Funny story. One of my training customers I got kicked out of after the class because I told their development team during the class, based upon what I was seeing in the system, and that the ISV solution that they had to build on was forcing recursive calls. I told them that they could not be successful developing on top of the ISV solution. 6 months later, that same customer called me in, had me sit across the table from the ISV to convince the ISV, hey, you need to restructure your plugin code and don't make the recursive calls. Next, let's talk about project structure of your CDS plugins. I have 2 reasons why I structure my projects this way. One is maintainability, and the other one is to control plugins. So yes, you can do things different, or I hear I could do that in 1 line instead of 5 lines. That's not a concern of mine. From a maintainability standpoint, as you can see, I have a simple folder and file naming convention of entity name plus message plus stage. Right away, other developers can see what the code hooks into. Next is controlling plugins. I hear many instructors say, have many plugins so it's easier to update. I am completely against having multiple plugins that aren't really aware of each other registered to the same entity message. This leads you down the road of recursive plugin issues with the pre-image, as we have already seen. My first level plugin always acts as a stub to call other logic. That's how you can control multiple plugins with inside a stage. In conclusion, I hope this video provided you with a few tips on plugin development. Thank you for watching, and thanks to my 1,000 plus students over the past 10 years.